Hello students. Next we are going to look how systems are represented. Already we have studied that if there is a system can be represented by its input-output equation. For example, if we are having a system in which there is an input which is x of t and we get an output out of the system which is y of t, then we can define this particular system by the equation which connects x of t and y of t. Another method is to basically define it using an equation h of t. Here we are talking about the representation of a system using differential equation, and that differential equation basically connects the input x of t and the output y of t. We have to remember that x of t is considered as the input and y of t is corrected as the output. By experience, people have seen that any linear system, when I say linear system, you should remember that we are talking about the system classification of linear and non-linear system. So any linear system which is also time invariant, that means it does not change with respect to time, such a system we will call it as a linear time invariant system, or in short LTI system. A general nth order linear constant coefficient differential equation that connects this input x of t and y of t is given by the following formula. For that, I will write the formula in a short form, which is written as summation of, let me use a different color. So summation of AK multiplied with the differential equation of yt of different order. So here the order is going to be k. So the kth order yt, such that the value of k basically goes from 0 to some nth order. So if it's a first order system, the value of capital N will be 1. If it's a second order system, then the value of capital N will be 2, like that for higher orders. So this is the part of y of t, which is the output, that will be equal to the summation of, again, k is equal to 0 to m. That means the m is the order for the input, bk into d by dt of kth order into xt. So this is the general equation that we can use to represent the differential equation of a continuous time system where we are having the input and output connected by a single equation. So if I am going to expand this, then I can basically write, let me use a different color. So if I am going to talk about the nth equation, so you can open up the summation. So I will write an d by dt of nth order y of t plus a n minus 1, that means just 1 less than capital N, so d by dt n minus 1 of y of t. Like that I will keep on going until it reaches a1 d by dt of y of t plus a0 y of t. So this is the output, that will be equal to, now I will write the input side, which will start from b0 x of t plus b1 d by dt of x of t, plus like that it will go all the way up to an, not a, b, sorry, bm d by dt of m of x of t. So this is an equation. Now if it's a second order equation, I need not say it specially. If it's a second order equation, you will have some a2 d by dt of yt d by dt square of yt plus a1 d by dt of y of t plus a0 of y of t will be equal to, similarly we will have in the other side. So I can write basically for any order, I can basically write this equation, and this equation, in this equation I will write where you know ak and bk are basically real constants. They are real constants. They are real constants, and we can basically solve this differential equation to get the value of y of t for a given x of t. So I will write here, and for a given x of t, we can get the solution. We can get the solution of y of t as, so what is the solution of y of t? Basically you have studied this in your mathematics. Y of t will basically have two parts. One is the particular solution, and the second is the homogeneous solution. You might have studied it in maths. Even if you have not studied, no worry, we are not going to use this in a big way here. Okay, so I will write that where yp of t is particular solution, and yh of t is basically the homogeneous solution. Which is also sometimes called as the complementary solution. Complementary solution. So this is basically the representation of a continuous time system using a differential equation. And we have already seen, in the previous problems, you have seen an equation which connects x of t and y of t. For example, I may have an equation like y of t is equal to d by dt of x of t. This is actually a differential equation representation. Or if I am going to write y of t is equal to 2x of t minus 2, this is also a kind of differential equation, but there is no differential component in it, that's all. So like that, the differential equation of a system, a continuous time system, is considered when we want to relate the input and the output of the system. Similar to continuous time system, we will have for the case of discrete time system. So for a discrete time system, we have a difference equation representation. It is different from differential equation. So difference equation is different, differential equation is different. So here for the case of discrete time system, we have a different difference equation, where again I would say that if you are having a system such that there is an output and there is an input of the system, and for every input x of n of the system, x of n of the system, we have an output y of n, and both of them are connected by a difference equation. Other than that, the system can also be represented as h of n, but h of n will not come into play. And just like we said in the case of differential equation for continuous time system, here also for representing the system we will have a difference equation. And for a linear time invariant system, that is an LTI system, a general nth order linear constant coefficient difference equation is basically given by, now here you can see there is a small difference in the equation. When we write the equation here, the equation becomes, it is summation, of course it is from k is equal to 0 to capital N ak, but instead of y of t or differentiation of y of t, we are having y of n minus k is equal to summation of k is equal to 0 to capital M bk x of n minus k. So this is a difference equation that is used for representing a discrete time system. So if I expand it, you can see it will be basically an y of n minus m, not m, n minus capital N plus a of n minus 1 y of n minus capital N minus 1. Like that it will go all the way up to a1 y of n minus 1 plus a0 y of 0. You can see that the equation is not having any differential component, but only the the output, the different output. So basically you are having a difference equation, and here it will be b0 x of n, sorry, this should not be 0, this should be y of n, okay, and plus b1 x of n minus 1 plus, like that, bm x of n minus m. So this is the expansion equation, or the expanded equation of the of the difference equation, and where you can write where ak and bk are real coefficients, or real constants, I should rather say, of real constants. So now, if you have to find out in this one, we don't have to struggle too much to find out what is the output, because the equation is very straightforward. The equation is very straightforward, because you can see that I want to find out this y of n. All you have to do is take the other part of the equation totally to the other side. So basically I can say that I can rearrange, so I can write, and for finding out and to find the output, and to find the output y of n, all one has to do is basically keep y of n this side, y of n I keep it this side, and the others I take the other side. So if I take the other side, 1 by a naught, which was basically getting multiplied with y of n, that will come, and then this whole equation is going to be there. So I will write summation k is equal to 0 to capital M bk x of n minus k minus, now this whole part, this remaining total equation, if I have to write the other side, I will write summation k is equal to, now summation k is equal to 1 to capital N, because 0 I have already taken, isn't it? This is 0. So k is equal to 1 to capital N a k y of n minus k. So this is the equation, okay, for finding out y of n. So you can see it's not a very difficult formula, it's a very simple formula for finding out. Okay, and this formula is basically called as a recursive formula. So let me write that also. So this is basically a recursive formula. So this is a recursive formula. And now you can understand, based on these equation of how you find out y of n using the equation, you can see that where the difference lies between a continuous time system wherein you have to solve the differential equation to get a particular solution, homogeneous solution to find out y of t, and whereas when you come to the discrete time system, looking at the equation directly, very easily you can get the output. And this very simple formula makes discrete time systems very, very attractive, and that is why the reason why now we have all these systems going into a digital form. Whether you take any equipment, most of them, they are going into digital format. Why? Because the system is very easily represented with respect to a recursive formula in the case of a discrete time system. So this is basically how we represent the system in in difference equation in the discrete time, and for the case of continuous time, how we represent the system in a differential equation form. Now you might be asking why we have learned this. It is just basically to understand how the equations are connected. Already we have dealt with these kind of differential equations and difference equations previously. If just to show you an example, if you would look at any of the examples that we have previously solved, for example, this equation is actually a difference equation. You can see y of n with respect to x of n is given. Obviously y of n minus 1 is not there. Or for that matter, let us take another equation, something that is having more. For example, take this equation. So this equation is another example of a differential equation which is connecting x of t and y of t. And if you want to find out y of t, obviously you will have to solve this differential equation. But anyway, nowadays we don't do that. So we will quickly jump over all these topics, and in the next topic we will basically see what is an impulse response of a system and how we can find out what is the output of a system, what is convolution. Everything we will study in the next part, and from there actually we will start dealing with what is the output of a system when we give a particular input to a system. Up till now you had studied what are systems, what are signals. Now you are going to study how and what is the nature of these, and how you can manipulate these for your advantage and all those things. Okay, thank you.